hypothesis testing of a population proportion using the critical regions method. Of the two methods, the probabilities method is easier if you're carrying out a straightforward test. In some questions they will ask for the critical region of the test or the exact significance level. In that case you have to use the critical regions method. I covered this in the previous video. In this video we look at the critical regions method. Example 1. H0, the null hypothesis, H1, the alternative hypothesis. So with a random sample of 30 and the p-value from H0, we have this binomial distribution. It's a one-tail test. We're using a 5% level of significance, so we'll use the number line method here, where x can take any value from 0 to 30. Because H1 is less than, the arrow is pointing to the left, we will have a critical region on the left hand side here, the lower tail critical region. So this region here, which starts from the critical value, is called the critical region. It's the region where we would reject H0 if our test statistic was to fall within this. In most problems, the maximum probability of the critical region will be your significance level. However, in some problems we want the probability of the critical region to be as close as possible to the significance level. So in that case you could have something that's slightly more than 5%, but I'm not going to look at those examples here. What we're looking at is a probability in the critical region that will be at most 5%, the significance level. So we have the acceptance region on the other side. So if our test value was to fall on this side, we would accept H0. To work out the critical value, we work with our 5% probability and we want at most 5%. So these are at most 5%, but this one is not. And the 0 and the 1 go in here, they go inside the critical region. And that's telling us that 1 will be our critical value. Px less than or equal to 1, and this probability is less than 5%, and it's good to show that 2 would not work as a critical value because the probability here exceeds 5%. The actual significance level of the test is the exact probability of the critical region, and that's not 5%. The exact probability of this region, Px less than or equal to 1, is 0.0480. As a percentage, it's 4.80%. This is called the exact significance level used for the test. And a test value that's 0 or 1 leads to a rejection of H0, and any test value from 2 to 30 would lead to an acceptance of H0.